For today's lesson, we're going to control the DC motor. So we're going to try to turn the motor on and off, vary the speed, and rotate it clockwise and counterclockwise in two states. So for example, we're just going to control it in either clockwise or counterclockwise position. And then for a three state we're in, it could be turned on and off, as well as it can be controlled in a clockwise or counterclockwise direction. So let us first start with the motor by turning it on and off. From the code last time, we used pin 3 and set it as output. Then the command would be pin mode 3 output. So we set pin 3 into high, and for the main or the void loop function, we wrote digital write 3 high. So it means we're going to turn on the motor. So let us try to do the simulation first in Uno Arduino Sim. So we're going to write 03 and then run the program. You will notice that the motor rotates in a clockwise direction. So to implement that, let us use an LED to mimic the motor. So you can actually write here 03. You will notice that the LED turned on. In the given program, if we're going to implement that using a PCB or just a breadboard, so we'll be needing an LED, a resistor, and of course our Uno board. We're going to copy this and then transfer this to your using the Arduino IDE. Okay, so this is now the program that we're going to download to your board. So let us first look at the actual setup. So this will be this module here is just the power supply that will be used to power up the device that we're going to use. Of course, this is our board. We're in the pins would be from pin 0 going up for the digital pins, and the analog pins from pin 0 going up to A5. So we have used pin 3. So first we're going to use the LED to simulate the given program. So you will notice that the terminals of your LED varies in length. So the longer one is the positive, so you can actually connect this anywhere. So just remember the polarity. Then let us use a resistor to limit the current that will flow through the LED. Then we can use this connector. We connect it to pin 3. Okay, pin 3, then to the positive terminal of your LED. Then the last connection would be from the resistor to your ground. So next, we connect the board to the PC. Now you can see that it has turned on. Then we need to download the program to the board. So verify first. So tools, so it is connected to COM3, so it has identified the Arduino board. So let us now download the given program. So it's now compiling. Uploading, and as you can see, the LED turned on once we execute the program. So let us now connect, instead of the LED, we're going to use a DC motor. So this is a type of DC motor. So it is actually a geared motor. It has 2 terminals. So we're just going to connect the 2 terminals into our board. So using a connector. So I'm going to get 2 wires. Okay, that I'm going to connect each side to the motor. Then I will just let the motor rest here, so you can see once the motor rotates. So I'm just going to remove the connector and replace this whole thing, the LDR and the resistor, with the motor. So before I replace it, so I'm just, let's see what will happen if we retain the LED and the resistor, if we're just going to parallel the motor to your circuit, you will notice that the voltage drop and the LED no longer light up. We're going to remove this so you have a current. Now, if we remove totally the LED as well as the resistor and connect the motor, still the motor is not rotating. So it means that the board or your Arduino cannot drive your motor. So let us try using a different source if it can power up your motor. So I have turned on this power supply module. I'm going to connect one side to positive and the other side to negative, and this one positive. So you will notice that the motor is now rotating in a counterclockwise direction. If I'm going to change the polarity from negative positive to positive negative, it should rotate on the opposite direction. So it is now rotating on a clockwise motion. I just used 3.3 volts here, so if I'm going to increase the voltage, eventually it would increase the speed of the motor because its rating is actually 5 volts. So I'm going to increase it to 5 volts. So you notice that the speed increases. So I'm just using 3.3 at the moment so that you can see the rotation clearly. So I'm going to turn it off for a while. Since the Arduino board cannot power up the motor directly, so what can we do is use a relay so that we're going to control this relay using our board. So this is the relay that we're going to use. So there are different types of relay. So some pin arrangement varies from one model to another. So in this given relay, the coil is connected just going to use a pen. So the coil is located at this pin and the other end of the coil is at the opposite side. Then the common is located at the middle of the pins of the coil. Then on top of the pin, we have the normally closed and the normally open. So which one is the normally closed and which one is the normally open? So you can either search it on the internet with regards to the model, or we could just use a tester. I'm just going to test the continuity. Okay, so you can see the continuity. So let us check for, okay, this one is connected and the other one is not connected. It means this two is normally closed and the one on the other side is normally open. So this is normally closed. So you can see that the sa value on the resistance, a very low resistance, unlike here. Then this is also the coil resistance. So you have their resistance. So if we want to connect the motor to the normally open position, once we energize the coil, it would shift from normally closed to normally open. So that will be the terminals that we're going to use. So I'm just going to leave it there. Then I'm going to use alligator. So this one, alligator clips, to test if the relay would shift from its normally closed position to normally open. Okay, so as you can see, with regards to the reading, now I'm going to use another connector to energize the coil. I'm going to turn on the power supply. So I have set it to so let us try to use okay. I'm going to use black for negative, then for it to be more visible, I'm going to use white for positive. I'm going to tap the positive to one side and negative to the other side of the coil. Okay, you will notice that I have applied the voltage but there's no response from the coil. Previously, as I've said, it was only set to 3.3 volts. Now I'm going to set it to 5 volts and see if, so apply positive to negative, if the coil would be energized. So as you can see, the coil are now energized. You can hear the clicking sound. Actually, I don't know if that's audible. So once you have this type of relay, once it is energized, it will now shift from one position, which is on the normally closed, to the normally open position. Okay, so be sure that you use the proper voltage for your relay. Another thing you will also notice that I have applied here negative and positive. So the relay was energized. What if I interchange the polarity? I'm now applying positive to the other terminal, which was previously we applied the negative, and now to the previously applied positive you're going to use negative. Still, the coil was energized. So it means you can use either or apply either positive or negative positive to either terminal of your coil. I'm just going to remove this to prevent shortage and turn off the power supply. I'm now going to connect this so the coil will now be used and we will connect it to the Arduino board. Just going to use another type of wire. I'm not going to use this connector, so male to female. Connect it to the relay. Since we want to energize this using pin 3, I'm just going to connect it to pin 3, then to ground of your microcontroller. Then after connecting that, let us use another set of wires to connect the motor okay. Then to the given supply, so positive, then the other side connected to the motor. So one terminal of the motor will be connected to ground, and the other terminal will be connected to the relay. So I'm just having trouble with the connection because the wires doesn't fit to the pins of your relay. So I'm just going to change the connectors and use the alligator clip. So instead of the earlier relay, so this is what I'm trying to use. So I'm just going to use a relay module. So this is a relay module. It still uses the same relay, but you have the built-in connection for the VCC input and ground. So this would be the red terminal for the VCC, so black for the ground, and brown for the input. Then you will notice here the NC. Don't know if you'll be able to read. So there's NC, normally closed, and the other side, this red one is the normally open, black is the common. So still you have the normally closed, normally open, and the common terminal. So it's much easier to use since it has a built-in slot for your wires. So it matches the male to female connector. This side will be connected to your Arduino board. So let us remove the excess wire. Okay. So let us just move this. Okay. Yeah. I just connected on the board the two terminals of your motor. One side will be connected to the Arduino board. So this will be for the ground. This one would be for the supply. So the red one would be the supply. So you can see that this one lights up. Then I'm going to connect this to pin 3. 0, 1, 2, 3. Then connect this to the supply going to one side of the motor. Then the other side of the motor will be connected to the ground. Now I'm going to turn on the supply and see if the motor would run. You will notice that the motor doesn't rotate even if we have used this program, for the one reason: if we're going to use the module, for us to turn on the relay, we need to send a low signal. So once we send a low signal, so the program was now downloaded. it instantaneously turned on the given motor. So I'm going to use 3.3 volts to reduce the speed and the strain on the motor. So it now turns in a clockwise direction. So I'm going to turn it off now. If we want to make it rotate on a counterclockwise direction, just interchange the terminals. The one connected to the positive will be connected to the ground, and then the ground will be connected to the positive terminal. So once we power this up, since supposedly the board is still running, it should rotate on a counterclockwise direction. So we try to, I'm going to turn it off again. Let us now revise the program in such a way that initially it would turn the motor off for 5 seconds. So digital right 3 high, so delay for 5,000 milliseconds, so that's 5 seconds before turning the device. Then we're going to wait for 2 seconds, digital delay 2,000, going to power up the device. As you can see, the same program was run. I am now downloading the program. The motor stopped, so approximately that would be for 5 seconds. It now rotates for 2 seconds. Then since this is done on your loop, it will continuously do this instruction until you turn off the power. So what if we want to do this once only? So let us cut this program and put it on your setup. So let's see what will happen if we're going to download this program. So 5-second delay. So it runs the motor continuously, even if we write here a delay of 2 seconds. Since there's is no command that will turn off the motor, so it will just continuously run even if we have set here a delay of 2 seconds. So if you want to turn off the motor after 2 seconds, just include the command digital right 3 high. We're going to download that. It turned off the motor for 5 seconds. It should turn on the motor for 2 seconds. Then eventually it turned off the motor. So that would be it for controlling your motor on an on and off state.